Okay, so I'm looking at standard number 5, solving for intersection points. We started to touch on this right before we went on our little break, but I'm going to jump in right here. So we'd had a conversation graphically about the different combinations we could have. So obviously if we were just looking at two lines, our instances are pretty small. We can have one intersection point. You can have no intersection point if they're parallel, and you can have infinitely many should they end up being the same line. We also took a look at one line and one quadratic. And in that case, for one line and one quadratic, you could have 0 intersection points because they might never cross. It is possible for them to cross at exactly 1 point. That point can be along the curve. Fun fact, should you hit a curve at a single point like that, then that line would be called a tangent line. And then we also have the case where obviously we could be crossing our quadratic in more than one spot or two spots. And then finally, we had the case of two quadratics. And similarly, we could have, hey, they intersect nowhere. They intersect in 1 point, which could look a couple of different ways because you could have two parabolas that just grow different sizes. And then they could intersect in 2 points, in which case you might have one up, one down. You could also have one skinny and one wide, or some other combination thereof. And then obviously you could have, like with two lines, the case where your two equations are in fact the same parabola, and there are infinitely many solutions. I'm not too concerned graphically right now. I think if you go in and we're looking at the assignment, you could graph the points, find the ordered pairs, and it wouldn't be too bad. What I'm going to focus on for the next few minutes is a reminder of the strategies we have for finding these points algebraically. So I'm going to jump to one of the actual problems on the assignment, and it asks to find the intersection point between y equals x squared plus 4x and y equals negative 3x minus 10. And there's two ways we can set this up initially. I'm going to show both strategies just because I think it's worth it to see, to be reminded of multiple methods. The first strategy I'm going to use is I'm going to recognize that both these equations are set equal to y. So I'm going to use the strategy of substitution. And substitution says that if I know y is equal to everything over here, I can replace every y with these values on this side, kind of like 4 quarters and $1. They have the same value, even though they look different. So by using substitution, you would be able to say that x squared plus 4x is equal to negative 3x minus 10. Y is equal to y, therefore the right-hand sides must also be equal to each other. If I wanted to solve this quadratic equation, I know it's a quadratic because I've got an x squared. Well, now I need to get everything to one side so that I can use one of my strategies. So I'm going to have to add the 3x and add the 10. I'm going to do that to both sides. And I now have x squared plus 7x plus 10 is equal to 0. Now that my equation is equal to 0, my strategies are possible. I could factor. I could use completing the square. I could use quadratic formula. Remember that you need it equal to 0 before you use one of those strategies. Personally, I'm going to jump to factoring because I see it pretty easily. Remember, anytime you've got a 1 in front of x squared, you're just asking yourself which numbers add or multiply to 10 and add to 7. So if I think about the pair of numbers that multiply to 10 and add to 7, right away I know that that's x plus 2 and x plus 5. We are at a point in our mathematical careers where if you don't have to make the area model and draw the box every time for these simple factoring problems, you don't need to. Now, if that's still helpful to you, if that's still something you feel like you need to do, by all means, that's okay. But as you get more comfortable, you are able to just jump straight down. At this point, if I wanted to finish solving this out, I'm going to set each piece equal to 0, x plus 2 equals 0, x plus 5 equals 0. Subtracting both numbers to the other side, I now have x equals negative 2, x equals negative 5. Now, here's the challenge before we complete this problem. If we think about it, we are finding intersection points, meaning those points should be ordered pairs. So what that means for this problem is I need to take my values for x and I need to plug them back in to one of my original equations in order to find the rest of my ordered pair. Doesn't matter which one I use, the whole point is they should give me the same value. So just for simplicity, I'm going to plug into the top one just because I don't want to deal with the extra negative signs. That's kind of my bias right there. So plugging into the first one, I get negative 2 squared plus 4 times negative 2. So that's going to be 4 plus negative 8 or negative 4. So I've got a first ordered pair of negative 2 comma negative 4. I'm going to do the same thing with my second ordered pair. I'm going to plug the negative 5 in, negative 5 squared plus 4 times negative 5 gives me 25 plus negative 20 or positive 5. So I get negative 5 comma positive 5. Hopefully I didn't make a mistake doing those. No promises or guarantees on that. If I did, please call me out on it. The only other thing I'm going to mention, because I think that's enough to get you going, is at the very beginning we could have taken a slightly different approach at the start. I initially showed substitution, and that's when I set each piece equal to each other because I knew they had an equal value. I substituted one part in for another. You could have used elimination. And what elimination would have done is elimination would have said, hey, I already know those y's are going to cancel if I add them together, or subtract them in this case. So in other words, elimination would have said, keep your first equation, keep it the same, x squared plus 4x. And what you're going to do is you're going to subtract your second equation. So that means I'm subtracting y. That also means this minus 3x is going to become a plus 3x, and this minus 10 is going to become a plus 10, because I'm subtracting every single part. Now when I do that, the y's are now gone, and I'm left with x squared plus 7x plus 10, which, sure enough, matches the equation we ended with substitution. It's just a slightly different way of thinking about it. The only thing you want to be careful of if you do elimination is it's really common to see students set it up properly, but when they get these y's to disappear, all of a sudden they think that this equal sign to 0 is no longer there. And now they're left with that, and they're trying to figure out what to move to the other side and where the equal sign goes, and they do some crazy stuff. So just realize that if you are combining equations, the equality symbol can't move. It stays put. You can move numbers and terms back and forth, but the equality symbol has to stay put all the way through. So I'm hoping that's enough to get you going on part 5. Again, I went a little on the light side because we had already started talking about this before the break.